Hello everyone, welcome back to Introduction to Algorithms and Data Structures. Today's lecture is going to be slightly different because, well, I really should have done this at the beginning of the week, but I realized I haven't really talked about the lab and the project, so I'm going to go over both of those. And I think I'm actually going to send out a notification to tell people to watch the first part of this video earlier before they start the lab and project, just to get them some basic info on it. And then I'm going to do a quick little introduction to insertion sort for Java arrays. Yeah, so the first thing is there we go. The first thing is the lab. So as you know from the syllabus and I guess my introductory lecture, we're going to have a lab every week except the first and last week. And these are just going to be basically ways to get you to practice your Java in a situation where, you can ask for help whenever you want. And it's not like graded in the sense that, it's just sort of graded on completion basically. But yeah, get some good practice and actually apply what you're learning in the textbook and in the lectures to actual practice. So there's lots of information here, but the idea of this lab is sort of to get you set up. So the first thing is just installing Java and creating a simple Java program, basically a hello world. I guess I won't really go through this in depth because it sort of tells you what to do. We have, this installing Java Canvas page has links on how to set up Java and also how to set up IntelliJ, which is a IDE that you can use. And then just creating this basic hello world. And then we just ask you to modify the hello world to print out your classes. So basically, just sort of alter it so that it now prints something else other than hello world. That's the first thing, and then you'll get that checked off. And then the second half of the lab is just more programming practice, not specific to Java, so you can actually do this in any language you're comfortable with. If you did 1133, then we would recommend Python because that's the language you learned then, but if you happen to know some other language, then that's fine as well. And we just have 3 quick sort of programming challenges for you to work on. So the first one is most common character. So given an input string, return the most common character from the string and the number of times it appeared. So data, it will return A, 2, because it's 2 A's, only 1 D and 1 T. So this little note, if there's more than one most common character, you can just return 1, it doesn't matter which. And also I think even Python might have just a built-in command that does this. But I'd ask that you don't just use that built-in command, but instead, manually go through the string and count and then return the answer. So, I guess if you're looking for a tip on this, go through the string one by one and keep track, and then you'd be able to count. Keep track for each letter and then return the one with the highest. That's probably a good starting place. Palindrome. Now just find if a sequence is a palindrome or not. So it takes a string and uses recursion to check if the string is a palindrome. So to check this, we'll just give you some strings and then say if they're palindrome. You have to say if they're palindromes or not. If you're looking for a tip on this one, I would say, you have this whole thing is a palindrome, but you want to use recursion, so you're trying to look for a sub-problem that would be helpful. Well, a palindrome, the first and last letter have to be the same. If they aren't, then you know it's not a palindrome, so you're done. But if they are the same, then what's the next step? Then the rest of it, without the first and last, also have to be a palindrome. So that's maybe an idea on how you might want to do this recursively. And then there's going to be you're going to have to keep track of odd numbered strings and even numbered strings are going to have a different base case. So just watch for that. Like odd number of characters. The last one's sort of an object-oriented practice. We're going to create a C circle class, which is sort of some basic functions. Basically just getters and setters. Although, yeah, circumference and area and diameter, these all sort of come from radius. And then, yeah, and then also something to check if they're equal. So, yeah, so basically just helping you remember how to set up a class with, functions and properties in it. So that's the idea for that one. Yeah, so you'll have all week to work on this, and yeah, feel free to pop into office hours to ask any questions. And then, yeah, once you complete a section, when you get to a milestone, just go to a TA's office hours and show them that it works, and they'll check you off, and then you'll be done. Yeah. Cool. So that's the lab. Let me know if you have any other questions. Yeah. Okay, so the project, this has just been put out. Oh, sorry. That's not at all correct, obviously. I updated it here. So this is due not the end of week 2, but the end of week 3. And so, yeah, you're going to have 3 projects in this class, and these projects are sort of laid out similarly to labs, but they're a bit bigger in scope, and instead of, getting as much help as you want and just getting checked off, this one you're going to submit, and it's going to be graded normally. So the idea of the project, well, so first is sort of like this README thing just to make grading easier for us. So just make sure you do this. And then, yeah, you can work with a partner if you want. And if you do, just submit 1 copy and include both your names. Yeah, etc. This is just general stuff. I guess, yeah, you can just read this. But the idea of this project is we're going to be drawing shapes and using recursion to create fractals. And so you're going to create these 3 functions for shapes. And these are just going to be like basically to create your shapes. And then we have this built-in function canvas that basically sets up the screen and can draw the shapes. And then you're going to have to edit Fractal Drawer to draw your shapes. So these 2, so this completed file is just available on Canvas, and then this file that you're going to need to edit is available on Canvas, and it has some other stuff in there pre-set up for you. So the first step is creating your shape classes. So this is pretty similar to the lab where you did the circle class, but there's a few extra things for each shape. So yeah. Oh yeah, and this is important that because we have pre-made code, you have to make sure you use the exact same names for everything as us, because the pre-made code has to work with it. So make sure you actually use all these things and spell them correctly. And if it's not working, make sure you spell everything correctly. So I won't go through all of these, but basically for each class you're going to have a constructor, and it gets like its position for the x and y, and then the radius for a circle. And then you're going to just have these calculating and then setting the color and value of of the shape. Yeah, and then getting and setting all the values. triangle class, similar, except now instead of just radius, you're going to have the position of the bottom left corner and then the width and height. And it's an isosceles triangle. So the width is just, the bottom side, and then the height is, you have your triangle and it's just the middle thing. So it'd be the hypotenuse of a right triangle with half the, So yeah, you just basically create all these classes. And then, so yeah, the three classes are similar idea to each other. And then this fractal drawer class is what you're going to be drawing these shapes and recursively drawing them to create a fractal. So if you don't know, a fractal is basically a pattern that repeats on itself at different scales. So like, well, actually like Sierpinski's triangle, there's lots of examples. So we're going to, and as you can see why this would make sense to use recursion to draw a fractal, because basically you draw the highest level, and then the next level you just draw recursively at a smaller size. And basically you repeat that down until you get a fractal. So yeah, here's a little example. So you have, basically the pattern is a triangle, and then you put triangles at each edge. So the first level, you just put a triangle at each edge, and then you put a triangle at each of those edges, and then you put a triangle at each of those edges, and so on. So yeah, this is what I already said. We already implemented the canvas class. And this is just telling you how it works. Yeah, so yeah, here's what your fractal wants to do. So you have to ask for user input. And use that as the base, and then draw a pattern that repeats itself at least 7 times and uses a new color on each repetition. And you have to do this using recursion. So theoretically, you could do this with like a loop that just says for I from 1 to 7 or whatever, and just make smaller each time, but you don't want to do that. You want to actually use recursion, so call your code again with updated settings. And then, yeah, so you want to draw your shapes at at least 4 shapes, and so on. Yeah, so the idea here is, well, yeah, maybe an idea for how to get started is, so you draw your first layer, and let's say it's a rectangle. And then you want to recursively call your function, like on the 4, we could say the 4 points of the rectangle. It could be the 4 sides, it could be the 4 points, but you do a recursive call that is a smaller size, and set the position to be at one of the 4 corners of the rectangle. And well, you have to do a recursive call, four different recursive calls for each corner. And then make sure you actually have some stopping criteria that's start with your counter at 7 and then you call it with 6 and so on. So you actually do stop eventually, because if you don't have a base case, then it'll just recurse forever and it won't work, it will crash. So be careful about that. But yeah, each level, you don't have to be aware of the upper levels, you just draw your shape and then recursively call either 3 or 4 copies in different locations with a smaller size. And then, here's some examples. So, so here you could just see we have a triangle, and then they recursively drew a triangle at each corner, and then they recursively did that a bunch of times. So that's sort of a very simple one. Is this one Sierpinski's triangle, I think? Anyway. this, you can get very creative with it, as you can see. Yeah, so you have 2 weeks to work on this, but it's good to get started as soon as possible. I think, yeah, the fractal class might take a minute to wrap your head around getting it to work, so definitely be patient with that. But this first half, I think, should be relatively straightforward. Cool. All right, so if you just popped in to see the first part where I'm talking about the project in the lab, then you can be done for now, because now I'm just going to go on to talking about insertion sort in arrays in Python. So this will just, where I'm assuming you've watched now the Monday and Wednesday lectures. So if you haven't done that yet, you can leave and watch those and then come back. Okay, so insertion sort. This is just one very common problem you have is you have a list of things, or in this case, an array of things that you want to put in sorted order. This is just a very common problem you might have in programming, and there's lots of solutions for it. It's sort of maybe the most prototypical algorithm, sorting. So insertion sort is maybe one of the easiest to understand algorithms for sorting. And I'm going to sort of first explain to you the idea behind it, and then I'll implement it for you and show you how it works. So we have this unsorted array, and we want to sort it. So insertion sort, the idea is we build up a sorted array at the beginning, a sorted subarray at the beginning, and then we just add new things into that sorted array in their correct position. So, for example, if we just look at the first element of the array, that's by definition it's sorted because there's no other elements for it to be bigger or smaller than. So you're done. And then we can look at the second element and see where does it fit in the whole array. So in this case, 5 is bigger than 2, so we don't actually have to switch anything. And now we know the first 2 are sorted. Then we look at the third element, and we want to insert this into this subarray in the correct position. So it goes between 2 and 5. And what we can think of is just we can move it past 5 and like scoot 5 forward, and then check 2, and 2's smaller, so we stop. So basically we just like scoot 5 over and slot 3 in. And so then we would have this. And then 1, so now this is sorted. Now 1, we can say, okay, 1 is smaller than 5, so we want to scoot 5 over. And then 1 is smaller than 3, so we want to scoot 3 over. And then 1 is smaller than 2, so we want to scoot 2 over. And then 1, well, then now we're at the beginning, so we just put in 1. 7's the same. 6 is smaller than 7, so we scoot 7 over. And then now 6 is bigger than 5, so we just plop 6 here. And so you can see we're just placing it in where it has to go, but we just, because you can only compare to one other value at a time, you just look at the current value you're considering. If it's smaller, you scoot that one over to make room for your value, and then you consider the next one. So that's the idea. And I think the textbook actually has a pretty good setup for sort of explaining how it works. So you could definitely check that out. But so anyway, here we have our values array, and this is how you create an array when you know all the values beforehand. You can just do this shorthand instead of doing int brackets vals equals new vals new int brackets. So then we're going to print out the original array, and then we're going to insertion sort, and then we're going to print out our sorted array. So now let's do insertion sort. So I sort of already thought ahead of time how I'm going to do this. So in reality, you might, go back and update stuff that you didn't think of. But in this case, I know that first I want to know how long the list is, because we're going to check that a few times, so I don't want to always check vals.length. It's just sort of easier to just have that as a variable. And now, as you remember, we already knew that the first element was sorted, so we just started at the second element and got that sorted, then we got the third element sorted, and so on. So we're just going to loop so we start at index 1, so the second element, and we loop through all the values until we get to the end. So this loop is going to go from the second value to the last value. So, and that's the current value that we're looking at is just whatever is in that position. So now once we have a current value, we just need to look at the value next to it and see if we want to swap that value. So, and then we sort of go backwards and see how far we want to swap our value. So we can say the location that we're considering swapping with, we'll just start it at I, because it's just sort of easier. So let's say this is our value, and we were seeing if we want to swap the value into its own spot. Like if we swap one value, it moves into the spot that is currently occupied by the value we're considering. And then, and we're going to want to loop, because we know we might want to just scoot it over 1, we might scoot it over 2, and so on. But we only want to swap if 2 things are satisfied. Well, first, swap value has to be greater than 0. Because, like, if it's impossible to move something into the 0th spot from the left. So we're never going to move anything into that spot. So we want swap end to be greater than 0. And also, we're only going to swap if the value that might swap into this position, so vals swap end -1, because like we're thinking of what we might put into the swap end position. We're only going to swap it if that is smaller. Oh, sorry, if that is if that is bigger than our current value. So, like 6, we only swap with 7 if 7 is bigger than 6. Okay, that's just because I haven't actually put anything in yet. So if it is true, if these 2 things are true, then we want to swap this value into the position we're looking at. So this is the value place we're swapping into, and we're going to set it to the value we're swapping from, because the value we're swapping from is bigger than our current value. And then we want to scoot 1 further up the list. So we can do swap end -, which is just swap end equals swap end -1. So, like, if we go back to if this was sorted, well, okay, just imagine this is sorted. I'll just quickly update it. All right. So let's say we're on our final iteration. So we're putting in 4. So once we go through this while loop, when swap end is equal to 7, we consider, is 7 bigger than 4? It is. So we put 7 in this position. And now we're looking at this position. Is 6 bigger than 4? Yes. So we put 6 into this position. Now we're here. Is 5 bigger than 4? Yes. So we put 5 into this position. And now we're here. Is 3 bigger than 4? No. So we stop the while loop and we're here. And swap end is now 5 here. So we've almost fixed it, but we got rid of 4. We basically covered up 4 when we were scooting everything over. So we have to put 4 in to the spot that we made for it by scooting everything over. So we can just, after this while loop, we can set val swap end to be curval. And then that should be done. So now if we run it, look at that. Oh, okay. Well, I changed this array to make it sorted already, so that didn't really. Okay, I'm just going to undo everything. Okay, so here now we have an unsorted array. And just do that last thing again. Vals swap end equals curval. Okay, now it is still sorted, but it didn't start out sorted. So there you go. Cool, so hopefully that was good and helpful to see live how insertion sort works. Next week we're going to get more into searching and sorting. Yeah, so look forward to that. Thanks for listening.